Okay, good morning, everyone. I think for the past few months, we keep talking about IR 4.0, IoT, all the advanced technology. So had you all ever think what happened after IR 4.0? So for today, I'm going to have a review about what happened in the past from industry 1 to industry 4. And then after that, we will try to predict what's going to happen after the IR 4.0. A quick revision. In the somewhere in 1760, the whole world actually having an industrial revolution due to the invention of steam motor. And in the meantime, there are many inventions. For instance, we have a tool and die, we have a textile industry. And during the period, actually many people lost their job because from agriculture society to the industrial society, there are many work and job opportunity have been replaced by the machine. So after some time in 1870, the whole world experienced a second revolution, also called as a technological revolution. The main invention in the second revolution is electrification. And in the same time, there are some important inventions such as telegraph and rail transportation. And in the same time, people start to have awareness and a concept of globalization, where people can easily communicate from a continent to a continent. When it comes to 1950s, it's quite recent. Maybe some people are born in that time of period. There are a lot of useful inventions that we are still using until today. For instance, the most crucial and important invention is the internet. I think imagine if we don't have internet by now, how can we, work from home? And besides, another important invention is the computer and also the mobile phone. And in this era, also called as a digital revolution. And come to 2010, start from Germany, people are talking about IR 4.0. And in IR 4.0, there are many advanced technology that have been highlighted, such as artificial intelligence, 3D printing, biotech, robotics, nanotechnology, and IoT. They are, in short, in IR 4.0, they call it as a cyber physical system, in which all the electronic devices, sensors, all this, they are actually connected in the cyberspace. And in this era, Malaysia start to react to the IR 4.0 in 2018, when Malaysia come out some transformation drivers to cater the future of IR 4.0. So after the industry 4.0, what happened? What going to be happen after all those advanced technology have been invented? Over here, I'd like to make a prediction. In IR 5.0, what happened is the whole world was facing a photon revolution. Maybe some of you are not familiar with what is photon. Basically, you can understand photon as light. I'm sure everyone are watching movie, and most of the movie that we watch to talk about future, the city consists of a lot of lightings, and they are maybe true. In the future, the whole world will be driven by the photon, but not longer electron. Okay, for now, our technology, our devices, electronic devices or any appliances, they are actually driven by the electron. But can you imagine in the future world, all the appliances, all the digital devices will be driven by photon? And actually, there's a vibe that we can see from about 20 years ago. One example, in the telecommunication, during the old time, we are transmit our internet signal by using electric signal. And also, I'm sure people heard about jamming, you have a data. They are all electrical signal. But about 20 years ago, we start to have a optical communication. And so the light, the signal is not longer transmit by using electron, by using light. So we have a fiberization. So as you can see, optical communication actually have been replaced the electron as a carrier for the signal. And 2 years ago, NASA, they have come out something more advanced. They actually shoot a signal by using laser from the ground, from the earth, all the way to the satellite. And the satellite act as a transponder and transmit, bound back the light, the signal back to the earth. So in this experiment, they actually successfully transmit a video more than 4 gig in about 2 seconds. So imagine in the future, you not even need optical fiber to do the transmission. You can just use the wireless to do the transmission, which is more efficient and more cost saving. And in this project, they call it as a lunar laser communication demonstration by NASA. Okay, of course, telecommunication is one of the major technology that link people together. Another important technology from the current world will be the power. For now, our system, we are using all the copper wire to build the high voltage tower to transmit the electricity from the source all the way to the terminal. But can you imagine how the cost that we have to invest to build all the tower? Actually, it's very high cost because the raw material itself is very expensive, the copper wire. But do you know, actually, since we can transmit the signal by using the optical fiber, why don't we build a system by using optical fiber to transmit the power as well? For your information, the raw material to build the fiber optics is actually sand, or you call it silica oxide. The cost of the raw material is so much lower compared to the metal. And not to mention, EADS agency in USA, they also invented some wireless power transmission. They call it laser power transmission. In this technology, they actually convert the electron into photon and then transmit the photon to another region by using high power laser. So in this case, you not even need any infrastructures. What you need is only a source, transmitter and receiver. Very simple. And another important technology that we are using every day is a computer. But I'm sure everyone heard about supercomputer and quantum computer. How actually quantum computer working? Actually, the quantum computer is not longer driven by the electron, but the quantum computer is to use photon to drive the motherboard. Why they decide to use photon? Of course, light have a faster propagation speeds, and besides, photon will not be affected by the EM wave, meaning that they will not have any interference in the supercomputer. So as you can see, from some major technology, telecommunication, power transmission, computing, we are started to transit from the electron system to the photon system. So there's no surprise. After another 10-20 years, the whole world going to have another evolution, which is a photon evolution, or maybe it's going to be a industrial 5.0. Okay, so come to some technology discussion. How to create a photon, or in another words, how to create a light. Let's go back to some fundamental science. For every atom in the center, we have a nucleon. And inside the nucleon, we have actually have a positive charge, or we call it proton. And outside of the nucleon is surrounded with orbit ring. And on the top of orbit ring, there are actually electrons floating on the orbit ring. And the electron is actually confined in the orbit ring due to the attraction force by the positive charge, or the attraction force by the nucleon. So the electron only can flow in the orbit ring but cannot go out from the orbit ring. So as what we have learned maybe in secondary school, When you give energy, in this case, energy can be in any form. That can be in vibration, that can be in electricity, that can be heat. When you give the energy to the atom, when the electron receive a sufficient energy, the electron may able to escape on the orbit ring. In this case, electron receive energy and escape from the orbit ring. So what happens if electron go back to the orbit ring? In this case, when the electron, a free flow electron, they give up the energy and go back to the orbit ring, the electron will release energy. Of course, this is physics. The energy never disappear. When electron release the energy, they appear in two forms. First is the photon, which is light that we are talking now. Another energy form that's going to be given up by the electron is phonon. Phonon is actually non-radiative. The meaning of radiative is the energy can actually go out from the atom itself. And non-radiative, the energy is still trapped inside the atom. So for the photon, it's referred to the vibration. So when the electron give up the energy, go back to the orbit ring, they will release two energy, which is a radiative energy, which is photon, and non-radiative energy called as a phonon. The phonon can be in vibration form, and eventually they are converted into heat. So as you can see, most of the appliances like lighting, LED, or this, they will incur some heat. This is because of the non-radiative energy emission. Okay, let's go to a very simple and very low-cost component, LED. I'm sure everyone heard about LED, and the cost of LED is only about 20 cents, or can be even lower. So how actually LED function? Based on what we have discussed just now, I will explain the function of the LED based on the solid state fundamental. In solid state, we have three bands, which are the valence band, energy band gap, and conduction band. Valence band is referred to when the electron are confined by the orbit ring and attracted by the nucleon. They are in a stable state. In this state, they call it as a valence band. Energy band gap is referred to the energy that required for the electron to escape from the attraction force by the nucleon and go to the conduction band. In conduction band, it's referred to the electron that can flow easily without any constraint or any force. In short, when all the electrons are confined in the valence band, the material is an isolator. For instance, rubber, where the electricity cannot flow through. And when there are some electrons can flow in the conduction band, the material is considered as a conductor, where the current can flow through. So what is semiconductor? Semiconductor is referred to some material in certain condition that can have electron to flow in the conduction band. And in another condition, there are no electron can flow in the conduction band. So how actually LED function based on the solid state fundamental? In a very similar concept, when the LED are connected to some electricity, they are actually giving energy to the valence band. When the electron in valence band, they receive energy, and in this case, the energy is referred to electricity, electron. The electron may receive sufficient energy to escape and to overcome the energy band gap, all the way jump to the conduction band. So in this process, we also call as a population inversion. By right, the electrons should be stay in valence band as a stable state, but by giving energy, electron able to overcome energy band gap and go to the conduction band. So in this case, the electron in the conduction band have received energy, and they are actually carry some energy. When there are many electrons go to the conduction band, in certain situation or by some chances and opportunity, the electron may being attracted again by the nucleon and go back to the valence band. In this case, this process called as a recombination process. Again, in recombination process, they will release energy, which is photon and phonon. And so this is how actually LED function and to light on a LED. And the heat is actually generated by phonon, where there's a non-radiative signal trapped inside the material and eventually turn into heat. So basically, this is a process, how actually LED function. Okay, let's have a quick revision for what we have discussed today. First, we have talked about IR4 from Industrial Revolution 1 until Industrial Revolution 4. And after that, we have tried to make a prediction where the IR5.0 will be a photon revolution, where the world going to drive by the photon, but not longer electron. And the statement is supported by some important technology start to transit to be driven by photon. For instance, the high power transmission, the telecommunication, and also the computer. And after that, we have discussed about the fundamental of how to generate photon. And before we end the section, we discuss about how actually LED function. And the concept is explained by solid state. Okay, so far any question? Any question from the floor?
No question.
How about my colleagues from engineering? Because
No
according to Kim, I need to prepare a Q&A section.
Okay, I got one question.
Yes.
Q&A section.
Dr. Teo.
Yes.
Yeah, Kim first. Okay, me first. Okay, Dr. Teo. How long are we away from photon technology? Meaning to say, how many years from now do you think it will take for photon to take over the world, so to speak, in terms of technology for energy?
Okay. Actually, the most crucial constraint by the photon to evolve mainly is because of the quantum computer. Actually, we still cannot have a very strong breakthrough in the quantum computer, or we call it as a supercomputer. Mainly it's because we have a way to store the electron, meaning that we can store the electron in the hard disk to drive the hard disk. But we don't have a very promising devices to store photon. And this is our main concern. So, and actually this is a hot topic in photonic engineering, where we are still looking for some solution to store photon or to use photon to drive a device, and that can be become a memory. So my humble opinion, based on what I have read, the evolution of photon will not happen within the 10 years. Will not happen.
Okay, 10 years is not very long. I mean, will not happen. Maybe if it's 20 years, it's still possible, like 20 years from now.
I would like to highlight because according to Moore's law, technology grow double for every 18 months. So what is not happening now? You know, that can happen maybe next year. But because of the scientific constraint, the physical, I mean, some technology breakthrough, I humbly believe that will not happen within 10 years time.
Okay, thank you, Dr. Teo.
Kim, you have questions? Just now Kim mentioned something.
I don't have questions. I don't have questions.
Okay. So any more questions? If no question, then I will just have my last slides.
Okay. Not Dr. Teo.
Yeah.
No Kahoot question and answer. Q&A.
Of course. Don't worry. I will do it when we come back to when we go back to the campus. I will have a Kahoot for you to make sure you understand what I'm talking today.
You got Kahoot, then not so many participants already.
Okay. Anyway.
King catch no ball. King catch no ball.
Yeah. Okay. Thank you so much for your time to attend for this section. I hope you learned something today, and also at least try to learn to know what's going to happen after IR 4.0. And one last thing, stay safe, stay home, and stay in touch. I hope I can see everyone very soon in the campus. And for the outsider, I hope I have time to meet you in our campus. Feel free to visit our campus to talk to our people. Right? Thank you so much. If there's no question, I will end the session.
Thank you.
Okay, thank you so much. Bye.
Wait.
Yes, Farah?
Can we take a photo first, a group photo? Can every one of you switch on
Yes,
the
of course,
video?
I'm good. I'm well prepared by setting my hair wearing a cord.
My God. Hi, Cik Iman. Okay, Mr. Iman is actually from JPN, Selangor.
Hi, Mr. Iman.
Leroy?
Can everyone switch on the camera so we can take a group photo?
Alan?
Robbie?
B? Hilang diri. Okay lah. It's okay. So everyone do your own freestyle lah. Huh? Okay. 3, 2, 1. Okay. All right. Thank you, everyone.
Okay, thank you. See you guys.
you.
Bye. Take care.
Bye.
Bye-bye.